Welcome to STEM Family Camp. Today we will be investigating methods for separating mixtures. We will be using the physical properties of different materials to separate them from each other. Then we will learn how to use two different chemistry techniques, paper chromatography and column chromatography, to separate food dyes from a solution like chemists. My name is Grace, and along with the rest of our STEM family team, I will be guiding you through this investigation into the ways we can separate mixtures. Why? Because we scientists have all the solutions. Get it? Solutions. Because solutions are mixtures, and that's what we are going to do today. Doing an investigation scientifically is different from just playing around. Scientists conduct their experimentation in a very deliberate way. In chemistry, it is crucial that the methods that are chosen to explore chemical interactions are chosen and ordered carefully. In this investigation, you will be separating a mixture by using one method at a time to remove each material. Like all scientists, you will make careful observations at every step of the separation. Scientists always record their data accurately so they can communicate their findings to other scientists. You have data charts in your camper instructions that you can use and then tape into your STEM Family Journal as a record of your work. Observe carefully and don't forget to write your findings down. A mixture is made when two or more materials are combined, but they are not combined chemically. That means that when you look at the mixture, you can still see each item as a separate thing. You could actually pick them apart and move them into separate piles, like these Legos. But if the mixture is made of small items or molecules, that type of separation would take a long time. An easier way to separate a mixture is by using the properties of each material. Is it magnetic? Is it soluble? Is it heavier? Lighter? With some creativity, these properties will systematically separate the items for you. Unfortunately, this type of separation doesn't work with a solution. A solution is a type of mixture that consists of two or more molecules dissolved in a liquid form, like coffee or juice or soda. Separating molecules in a solution can be tricky. However, scientists have developed some techniques that separate the molecules out of a solution. One separation technique is called paper chromatography. If we put a small amount of the solution on a strip of paper, the different molecules will be carried up the paper by a solvent. As the molecules move up the paper, they are moving against gravity. The big molecules are heavy and will not move up very quickly against gravity. The smaller molecules are lighter and will move more quickly up the paper. This separates the molecules so that scientists can identify what they are. Another separation technique scientists use is called column chromatography. Column chromatography uses gravity, but it also uses pressure and solubility to separate the molecules. This takes several steps and often takes a long time to complete. Pressure is used to push the solvent through the column. The column is filled with either gel, sand, or powder that interacts with the molecules in the solution. This affects how quickly the molecules move through the gel, and we can capture the molecules as they exit the column one by one. Today, you will be using all three separation techniques. For our first experiment, we are going to use the properties of materials to separate a mixture. Here are the materials you will need for this experiment.
Okay, you will have a bag containing a mixture which has iron filling, sand, salt, and black pepper. And these are your tools to separate the mixture. We have a cup of water, a plastic spoon, wool felt, and a ceramic magnet. This is also very messy, so make sure to protect your space.
One of the materials you have to use is a magnet. Magnets create an invisible charged field around themselves that can attract or pull on some metals. If a material in a mixture is attracted to a magnet, the magnet will pull that material and the force can be used to move it out of the mixture. One of the materials in this mixture can be moved by a magnet. Put your magnet in a plastic bag and run it over the mixture to lift one of your materials out. Remove that material and place it off to the side on your paper. Which one is it? Record your observations on Table 1. Static electricity is another method you can use to remove a material from your mixture. Static electricity can be created by rubbing one object against another. This creates a charge. One of the materials is lightweight and will be lifted out of the mixture with static electricity. Rub a plastic spoon and your wool felt together to create a charge. Then, hover the spoon above your mixture to attract one of your materials. Remove that material and put it off to the side on your paper. Which one is it? Record your observations in Table 1. You may need to do this step many times in order to remove all of the material from your mixture. The final method we'll be using to remove one of your materials from the mixture is solubility. Solubility is the ability to dissolve in a solvent like water. When a material dissolves, it will no longer be visible because its molecules are hidden between the water molecules. It forms a solution. Materials that cannot dissolve will remain visible because they are not a part of this solution. One of your materials is soluble. Put the remainder of your mixture into a cup of water and stir. The soluble material will dissolve in the water. Pour your new solution into an empty cup so that only your final material remains at the bottom of your original cup. Record your observations of your final two materials and what happened in Table 1. Make sure all of your observations are recorded in Table 1 once you finish separating your mixture. What was the final material left? Which method removed each material? What was it like to use magnetism, static electricity, and solubility to remove materials? Can you still see all of your materials? These are all important observations for us to keep track of in this investigation. Now it's your turn to test out these 3 different separation methods. Pause the video now to follow our procedure for using the properties of materials to separate a mixture. For our next experiment, we will be testing out how paper chromatography works to separate a solution.
So for this experiment, you will need a plastic bag with salt, water, 2 cups, 2 binder clips, and 2 chromatography pieces of paper.
You will also need a pencil, 2 measuring cups of water, 2 popsicle sticks, 2 Q-tips, 2 Kool-Aid packages, 1 lime, 1 grape, and you will need a roller.
The first thing you're going to do in this experiment is put 20 milliliters of water into each of your 2 medicine cups. Then open the grape Kool-Aid packet and pour all of the powdered mixture into one of the medicine cups. Stir the mixture until it's completely dissolved and then wash your spoon because you're going to be using it again. Then follow the same steps for your lemon lime Kool-Aid and your other medicine cup full of water. You're going to stir it with your spoon again and then rinse your spoon because you're going to be using it later in this experiment. Now it's time to set up your paper chromatography strip. Using a ruler, measure 4 centimeters from the bottom of the paper strip and draw a line across the width of the paper. Then at the top of the paper, write grape. Then follow the same instructions for your second piece of chromatography paper, but label the top of this paper lemon lime. You can see a picture of this in your camper instructions. Next, take a clean cotton swab and stir the grape Kool-Aid solution until the cotton swab is soaked. Dab the cotton swab on the edge of the medicine cup or some paper to ensure that it's not too wet. Then, lightly touch the cotton swab to the center of the pencil line on your paper strip. Let it dry for 1 minute. Repeat this process 3 more times until the mark on your paper strip is very dark. Then, set aside your paper strip and solution. You will then follow these same steps with your lemon lime Kool-Aid, your other paper strip, and a clean cotton swab. Pause the video now to follow our procedure for setting up your solutions and paper strips for this chromatography experiment. Now it's time to set up your chromatography cups. Pour your salt into the 9-ounce cup of water and stir until it's dissolved. This is going to be your solvent, and it's going to dissolve the dyes on your paper strips. Next, set out your 2 empty 9-ounce cups. Pour 2 centimeters of your salt solution into each cup. You can do this by holding a ruler next to the cups as you pour your solution, like we're doing in the picture here. Now let's set up your paper strip hanger. To do this, you're going to wrap the top of your paper strip over a craft stick and then secure it with a binder clip. How do you know where to fold the paper? Hold the paper strip next to your cup. You should fold your paper at the place where the top of the cup and your paper strip meet. Then fold your paper, put it on the craft stick, and secure it with the binder clip. Finally, place the hanger across the cup so that your paper strip is suspended in the liquid. You will see the solution begin to rise up the paper. Then you're going to let it sit for about 5 to 10 minutes so it can do its work. After your 10 minutes are up, remove the paper strip holders and the craft stick. With your pencil, draw a line across the top edge of the wet area of the paper strip. This is called the solvent front, which is how far the salt water could move up the paper. Then allow your paper strip to dry. Once your paper strips are dry, tape them into Table 2 and analyze what you see. What two colors appeared? How far did the dye move up the paper strip? It's amazing what a little chemistry can do to our Kool-Aid. Pause the video now to follow our procedure for setting up and observing your chromatography strips. Nice work so far! For our final experiment today, we're going to use column chromatography to separate a solution. In this experiment, we will need 5 medicine cups, 1 9-ounce cup with 2 centimeters of isopropyl alcohol, 1 9-ounce cup with 2 centimeters of water, 1 9-ounce waste cup, 2 10-milliliter syringes, a Sharpie, 4 cups of water, a pitcher or large bowl for mixing, our grape Kool-Aid solution from Part B, a cotton ball, a pencil, and 2 tablespoons of Mystic sand. To get us started with this experiment, the first thing we need to do is make a diluted solution of our grape Kool-Aid from Part B.
So we have 2 cups of water already in here, and we're going to add 2 more cups.
And then we're also going to add the Kool-Aid that we used from the previous lab into the bowl.
Once you stir your new grape Kool-Aid solution together, it's time to set up and organize your materials for the rest of the experiment. You want to make sure your setup materials look like the diagram on this slide. With your Sharpie, make sure to write an A on the top of your syringe. This is going to help you stay organized later on in the experiment.
Okay, so now we have everything set up and we need to go about setting up our column. To do this, we need some things. We need the second syringe, we need the magic sand, we need a cotton ball, a pencil, and a Sharpie. We're going to use the Sharpie right away, and this is the only thing we'll use it for. We just want to label our syringe with a B so that we know that this is syringe B. You'll be able to tell that anyway because it's going to be the one with the sand, but it is helpful to always have that in eyeshot. Then, once you have that done, you're going to remove the plunger. We're going to take a little bit of the cotton ball, not a whole lot, but enough so that the sand won't fall through. And we're going to use the end of a pencil to tap it down because you don't want the cotton to be more than 1 milliliter in space, okay? Because it really is just there to keep the sand from falling through. The next thing that we're going to do is we're going to add the magic sand. So we're going to pour this in so that it's up to 5 milliliters. And so this is about 5 milliliters. And then we're going to tap it down. And the reason we do that is because the sand needs to be compact. And when I do that, you can see how much the sand actually goes down. So I'm going to add a little bit more magic sand. And I'm going to tap it down again. We want the sand to be at a level of about 5 milliliters, maybe a little bit above, but not too much. And that seems to have been enough. Okay, so I'm now going to take this, I'm going to put this in the waste cup so that it stays upright, and I'm going to get the next part of this completed. So we have our column set up and it's sitting in our waste cup. We are going to need to prepare it for the Kool-Aid, and to do that we'll need a few things. First, we're going to need syringe A. We're also going to need the rubbing alcohol that was sent to us and the water. So what you're going to need to do is take syringe A, and we're going to start with the alcohol, and you're going to pull up on the syringe so that you get 5 milliliters of solution. Now, this may take a moment because our syringes are new to get the air bubbles out, but you can see I have 5 milliliters of alcohol. Now, our sand has a coloration to it, and that is going to screw up our chromatography. So we're going to need to clean up as much of that color as we can, and the alcohol is going to help us to do that. So the way I'm going to do this is I'm going to hold this over the cup, and I'm going to need both hands. I'm going to hold syringe B in one hand and hold syringe A over it. And you can actually rest it on here. And then you're going to put the rubbing alcohol into the sand. Now you want to do this kind of slowly because you don't want to disturb the sand too much. And then we're going to apply some pressure. That's the great thing about column chromatography, is that we can apply pressure. But when I put the syringe in, I'm going to have to be careful, because as I do it, and you can see the colored alcohol coming out, but as I do this and force it through, when I pull back on my syringe, which I'm going to do in a second, you can see it kind of pulls the sand up. So I have to be really careful and kind of move it in and out so that I don't disturb the sand too much. And you can see down in the bottom of the waste cup that the water is, or the alcohol is actually yellow. So even though it doesn't tell you to do this in the directions, we're going to actually do this alcohol wash a couple of times. Magic sand comes in multitudes of colors, and it comes colorless, but that is not what we always have access to. So if there's coloration, you want to prepare the syringe so that you get as much, oh, that was bad. That's exactly what you don't want to do. But you want it so that you get as much of that yellow color out as you can. So we have found with the yellow that washing it 3 times seems to be pretty good. And again, you can see as I pull up on the syringe, I'm being careful not to disturb the sand. I'm going to do one more alcohol wash. So, and you may need some help. This is kind of tricky. You could actually put the syringe down as you're pulling up on the other one, because it's not going to go back up into the syringe. And here we go. I'm going to put the alcohol in one more time. And you can see it going through. And I'm pressing this out. Oh, it's much better. It's much clearer now. And I'm going to try and get all of the alcohol out if I can, so you can see where it's really just mostly bubbles. I'm going to push down and very carefully pull the plunger back out. All right, now I'm going to leave this to rest in here for a moment, and I'm going to do a final rinse. It's going to be water, the same 5 milliliters. And again, I'm going to put this into the syringe. And this time it's just water in there, so we're going to rinse this out. Now this is preparing the sand so that it will attract hydrophobic molecules that are a little bit afraid of the water, and that's going to help us to separate things out. All right. You can see why it's important to have a waste cup as well. All right, so I'm going to very carefully pull this out. And now our column is ready for the Kool-Aid.
Pause the video now to follow our procedure for getting your materials and column set up for testing the Kool-Aid. Feel free to go back and watch the video instructions again if you need to. This is a tricky one. The first step in separating the dyes in Kool-Aid is to add our Kool-Aid. So take your empty syringe A and use it to slowly suck up 5 milliliters of grape Kool-Aid. Then carefully remove the plunger from syringe B, which is your column, and hold it over your first medicine cup. Then slowly push the Kool-Aid from syringe A into syringe B, trying really hard not to disturb the sand too much. And then you're going to let the Kool-Aid drip out of syringe B, or as we did when setting up our column, you can use the plunger to push the Kool-Aid out a little bit faster, but again, be careful not to disturb the sand. Once you do this, look at the color of the liquid that comes out of the syringe. What color is it? What color is the sand in the syringe? Write your observations in Data Table 3. Step 2 of this experiment is very similar to Step 1, except instead of Kool-Aid, you're going to use water. So take your empty syringe A and use it to slowly suck up 5 milliliters of water. Then carefully remove the plunger from syringe B or your column and hold it over your second medicine cup. Then slowly push the water into the sand. Try not to disturb the sand too much. You can let the water drip out of syringe B, or you can use your plunger to help it along and speed up the process. As you do this, take note of what you see. What is the color of the liquid that comes out of the syringe? What is the color of the sand in the syringe? Has it changed? Write your observations in Data Table 3.
All right, so Melissa's going to take the rubbing alcohol and 5 milliliters of that we're going to put into the syringe, and now it's over our third cup. And if we see the drop of color change, we're going to move it to the next cup. Awesome. She did a great job, and you can see the separation of color.
As you do this, observe what's happening. What is the color of the liquid in the third cup versus the fourth cup? Are they different? What happens to the color of the sand in the syringe? Write your observations in Data Table 3. For our final step, we're going to do one last separation to make sure that we got all of the color out of our sand. So to do this, we are slowly going to suck up 5 milliliters of isopropyl alcohol into syringe A and hold syringe B, our column, over our 5th medicine cup. Then we're going to slowly push the alcohol from syringe A into syringe B and let it either drip out or use our plunger to push it through the syringe. As we do this, we're going to observe the color. What color is the liquid in the 5th medicine cup? What happens to the color of the sand in the syringe? Write your final observations in Data Table 3. You all have done such a great job today. Based on Table 2 from Part B and Table 3 from Part C, we can conclude that purple Kool-Aid is really made of red and blue dyes. You just watched chemistry at work. I hope you had fun today investigating all the different ways that we can separate mixtures. I know we did. STEM Family Camp is a product of iBio, delivering industry-led STEM programs for teachers and students to inspire a new generation of innovators and entrepreneurs. To learn more about iBio and its programs, visit www.ibio.org.